Okay, problem 104, page 4, I think 489. Yep, 489. You have a sister that is page 489, 102. And this is back to establishing trig identities, and here is an expression that the problem is asking you to show that the left-hand side can be converted into the right-hand side. And, step back, catch your breath, say, what's going on here? And remember, when you see arc functions, what are arc functions? Arc functions are angles. So this is cosine of A plus B, where A and B are angles. A is that. In fact, let's write that down. And we kind of grounded here. Let's just say, let's let A be equal to the arc sine of nu, and maybe you're a little freaked out by seeing Greek nu for the first time. And at the same time, let's let B be equal to arc cosine of nu. They're both angles, and so be it. That means what we're doing here is the cosine of A plus B is equal to 0. Oh, that makes me wonder if we should do this another way. If the cosine of A plus B is equal to 0, then A plus B is pi over 2, but I don't think that will help us. So let's just move on and do it as I first thought we were going to head for. Let's go ahead and expand this out using the sum of angles for the cosine. So A plus B, cosine is the one that goes cosine A cosine B. Plus gives you a minus sine A sine B. Okay. So now what? Well, now here's let's now go substitute A and B back. I only put A and B in for a moment so that you could see that this strange looking expression is not that strange at all to you, presuming that you're thinking that identity is not strange. But let me go expand it back out and get cosine of the arc sine of nu times cosine of the cosine of nu minus the sine of, what is A? A is the arc sine. And sine of B, what is B? It's the arc cosine of nu. Okay, so a couple of these are fairly easy to do, right? Here, the cosine of the arc cosine is going to give you back nu. Sine of the arc sine is going to give you back nu. The two guys we have a little issue with is what is the cosine of the arc sine and what is the sine of the arc cosine. And we've done problems like that, right? Just got to draw our triangles. Right over here, this angle, let's go since this is funny Greek letter day, let's go psi is equal to the arc sine of nu, right? Psi is the angle whose sine is nu. So psi goes right into there. This is psi. And what do I want? I want a nu over here and a 1 over there such that the sine of psi is nu. And if it works like that, then 1 minus psi squared to the 1/2 goes down here. And that means that the cosine of psi, which is equal to the cosine of the arc sine of psi, is equal to something. It's equal to the adjacent over the hypotenuse, or 1 minus psi squared square root. So, I really wish I hadn't put that right there. That just says that the cosine of the arc sine is 1 minus nu squared 1/2. Right here is the cosine of the cosine of nu times nu. Let's go over here and work on this now. I've got minus nu, and let me go find the sine of the arc cosine. I'm going to say that phi is equal to cosine minus 1 of nu. That means that phi is the angle whose cosine is nu. So let's draw another triangle down here. Should have changed colors maybe. There's phi. Its its cosine is nu. So there it is, adjacent over the hypotenuse is 1. We know then that this side is nu squared to the 1/2. And that says that the sine of phi, this is a phi, the sine of phi is equal to the opposite over the adjacent, or 1 minus nu squared to the 1/2. I put that right in there, right? Sine of the cosine, right? Sine of the cosine to the 1/2, and I get this quantity minus this quantity. Guess what? It's 0. And if you follow the logic through this, we just made transformations of this original quantity into this sum and difference formula, and then made use of this means in which we calculate these composite functions to show that indeed the left-hand side was equal to 0.